In this session, we will introduce role-based security and access control in OutSystems. We will start by defining what access control is, and why it's important. Then, we will talk about end users of our applications, as well as roles and how can we use them to grant permissions. We will finish by discussing how can we check for user permissions in our applications. So, what is access control? Access control determines and enforces who can do what in our applications. By who, we mean the users, or groups of users with a certain role. While the what defines resources or actions we allow those users to take, such as accessing screens, or adding certain data to the database. In general, access control comprises authentication and authorization. Authentication is about who does something. We need to identify who is accessing our application and then validate their credentials, like username and password. Then we have authorization, which is about what someone does. This requires that we validate if a certain user has the required permissions to do what they want to do. Let's now start by defining who are the end users of our applications. In OutSystems, end users are created and managed in the built-in users application. This application is the default OutSystems user provider, and it has a back office that you can access using the browser. In this back office we can create and manage our end users. The core information that identifies a user is the username and the password. The users can also be created programmatically in our applications. The users module has a set of actions, including create or update, that we can use inside logic flows. Now that we have users, it is important to determine what they can do. In OutSystems, authorization is granted through roles. Roles are elements that we can easily create in our applications in Service Studio. There are two built-in roles, anonymous and registered. Any user has the anonymous role, since it includes anyone that may access our application, even if we don't know who they are. Then, every user that is registered in our users application has the registered role, which means any authenticated user with a username and password. Apart from these two roles, you can create as many application-specific roles you want to, and use them as well to handle authorization in your applications. Each role has three built-in server actions you can use: check role, grant role, and revoke role. Like the name of these actions indicate, they are helpful to allow you to check whether a certain user has their respective role, for instance the manager role, and also to grant a user a role, or revoke it. As we discussed before, authorization is granted via roles. For that, we need to assign roles to users, so they are able to do whatever we define that users with that role can do. Authorization can be managed programmatically, using the grant and revoke actions. These actions expect the identifier of a user and can be used in any server action flow. Or we can do it manually in the user's application. By opening the details page of a user, we can choose a role and explicitly assign it to the user. We already know how to assign roles to users, so that they have the permissions to do whatever the role allows them to do. However, how do we define those permissions? How do we check if a user can perform a task? Well, roles can be checked in screens and actions. There's a screen roles property in every screen. That property has a set of checkboxes, one per role, that we can tick or untick to allow or restrict access of a certain role to that particular screen. This way, only users with the roles ticked in this property are allowed to access the screen. For instance, if the anonymous role is selected, everyone can access, logged in or not. If only the employee and manager role are selected, like in the example shown here, then only the logged-in users that have the employee or manager role can access the screen. Also, using the check role action, we can check in a logic flow of a server action if a certain user has a certain role. Then, we can build our flow to make sure that only the users with a certain role are authorized to perform a certain task. For instance, in the flow on the right, we first check if the user has the manager role. If it does, then we create an employee in the database, otherwise an exception is thrown. In sum, there are three parts that compose access control. We create and manage the end users in the built-in users application. Then, users can have roles assigned to them. And then, we check the permissions to perform a certain task, based on the role. This way we guarantee that only users with that role can perform that task.